All right, number 6 here was on a recent AP exam. It gives us a differential equation. We have an initial condition of 0, 1. And the first thing we're asked to do is take the slope field for it and find the solution curve that goes to the point 0, 1. So what they're expecting us to do is to go first to 0, 1, which is right there. And then to try to just trace through as best we can kind of what this looks like. So if you kind of follow the marks, again, don't go through anything, just let them guide you here. You can see we're starting to turn right about here, and then we're heading back up. And so you just kind of trace out and let them guide you here. That's what's happening on this side. And then over on this side, if I kind of trace this out, I see it flattening and then bringing me back down to here. Okay. Now they give you a little bit of leeway, but you can't have something crazy. You can't have this going just straight off the graph or going down. As long as it looks something like that, you can give yourself a point because that's what they did back then. All right. For part B, it says write an equation for the tangent line to this at the point 0, 1 and use it to approximate 0.2. So every time we see tangent line, we're thinking point and slope. The point was already given to us, 0, 1. What we need to do is find the slope. So in order to find the slope, we're going to put 0, 1 back into this differential equation. So I'm going to go ahead and put 0 in for x and 1 in for y. It's going to give me 2 times the cosine of 0, which is 1. And so 2 times 1 gives me a slope of 2. Now you may want to show that. Never know what the grader is going to want. So I say dy dx at 0, 1 is equal to 3 minus 1 times the cosine of 0, which equals 2. Just in case they get a little crazy about that. All right, so now we can make the equation of the tangent line at least. Y minus y equals slope times x minus x. And if you want to distribute and bring it over, you could even make it 2x minus or plus 1. Either one of those would give you a point. The tangent line equation by itself was worth 1 point that year. Okay. Now they're asking us to use it then to approximate f of 0.2. So this is in the x spot, so we're going to put it in the x spot. So f of 0.2 is approximately 2 times 0.2 plus 1. So this is 0.4 plus 1, so we get 1.4. That's our approximation. And if you had that, give yourself another point. Now, last step here is where all the big points were. Can we find the particular solution that goes through that right there? So in order to do this, we're using the same stuff we've been doing all week. We're going to move the y part over. So when you do that on that differential, it's going to be dy over 3 minus y equals cosine x dx. If you did that separation, that was worth 1 point. Now we're going to integrate. Dy over 3 minus y equals the integral of cosine x dx. Now this side's easy enough. That's just going to go to sine x plus c. This is where you got to be real careful. The derivative of 3 minus y is not dy, it's negative dy. The derivative of this would be a negative 1. So you can either include that and make this the negative natural log of 3 minus y. And then if you think about it, the derivative of this would be 1 over 3 minus y times negative 1, which would cancel this negative and give us the positive. Or you can do this as a u sub, if it would be easier. Make u equal to 3 minus y and do your derivative and kind of work it off to the side and then bring it back when you're done. Either way, this negative has to be there. Now they gave you a point for this integration, and they gave you a point for that integration. What the graders will do is if you forgot that negative, if you just did natural log and you kept going in the problem, they'll grade it okay, based on what you wrote. They'll give you points for what you deserve, even if you messed up earlier in the step. So just keep going. Don't worry about an integration. If you're not sure about how something integrates, just even make it up. Just write something down and keep going is better than to just stop and say, I'm not sure. All right, so we're at this stage here. We need to figure out what that C equals. Again, back then they were very generous. They gave you a point for remembering to put plus C down. And then they gave you another point for figuring out what it is. Today they wouldn't, they just give you 1 point total. So we're gonna go ahead and put 0 in for X and we're gonna put 1 in for Y. So we get the negative natural log of 2 equals the sign of 0, which is 0 plus C. So we end up with C equal to the negative natural log of 2. They would have given you 1 point for that. Okay, plug that back in. We get the negative natural log of 3 minus y equals sine x minus natural log 2. This is looking pretty ugly, but this is what we have to solve for y. So let's go ahead and multiply by negative 1. This is going to give us natural log of 3 minus y equals negative sine x plus natural log of 2. I'm just going to change the order there for my own sense, but it doesn't matter. Then we're going to raise it power of e. So now I'm going to get 3 minus y equals e to the natural log 2 minus sine x. And we could split that into e natural log of 2 times e negative sine x. And e to the natural log of 2 is 2. So I can get 2 e to the negative sine x. Again, that's a step you don't have to take, but you'll see the AP do that quite a bit. All right, last thing for us to do is to figure out if this is going to be positive or negative. So if I put 3 minus y down, I want to take my initial condition again and see what it has to be. So if I put 0 in for x, sine of 0 is 0, e to the 0 is 1. I get just 2 over here when I do that. So if I put 0 in here, I'm going to get 2. If I put 1 in for y, I'll get 2. So I want that to stay positive there. I don't want the negative version of that. We're going to subtract 3. So negative 3 plus 2 e to the negative sine x. And the last thing to do is multiply everything by negative 1. And we're going to get y equal to 3 minus 2 e to the negative sine x. That's a lot of work for just 1 point, but that's what you get. All of that right there gets you 1 extra. Over here, again, 1 for the separation, 1 for this integration, 1 for this integration. Today, probably just 1 for that c, but back then they gave you 2, and then 1 for all of this. So even if this seems really scary to you, don't panic. Look, there's 6 points they gave back then. 5 of them were over here. All stuff that we should be able to navigate. Most people can get 4 out of these 6 or 5 out of these 6. So that's how you got to approach this if you were to see this on May 5th.